Hey guys, welcome to the 2016 Level 2 Waves exam. For this video, I'm going to be walking through the 2016 Level 2 Waves exam. So I'm going to get straight into it. Question 1, light. Tim was looking into a convex mirror ball in his garden. Standing behind a small plant, he noticed that when he looked at the reflection of the plant in the convex mirror, it appeared smaller than it really was. Complete the simplified ray diagram above, not to scale, to show where the image of the small plant would appear. So as you can see, we have the two rays, okay? So one ray is traveling parallel to the horizontal axis, and the other one is traveling downwards. And if I kept extending the ray forward, it would hit the focal point, okay? So first of all, we need to draw the ray diagrams for both of these rays, and then we need to find the point where both of these rays meet, whether real or virtual, and we need to find where the image is formed. So I'm going to start off with the first ray, which is a parallel ray that is parallel to the horizontal axis, okay? So the law states that when the ray travels horizontal parallel to the horizontal axis, it is going to reflect back upwards, but if I extended the ray backwards, it will be passing through the focal point. So reflecting back but through the focal point, okay? So what I mean is this ray is, if I extended it backwards, it will hit the focal point, okay? So I just need to adjust this a little bit. Yep, so the ray will look something like this. It will reflect back, but if I extend it back, it will go through the focal point. Our second ray, as you can see, if I kept extending it forward, for example, if I kept continuing this ray, just for example, you will see that actually goes through the focal point, okay? That's important to note, okay? And that's because one of the laws state that if the ray is traveling through the focal point in the convex mirror or concave mirror, it's going to reflect back parallel to the horizontal axis, okay? So this ray number 2 is going to reflect back through the horizontal axis, parallel to the horizontal axis. So right now, as you can see, there's no way that these two real rays will meet. The upper ray is going to keep traveling upwards, while the lower ray is just going to keep going in that same direction. So they're never actually going to meet. What we're going to do now is going to extend the rays backwards to create the virtual rays, and we're going to find out where the virtual image is formed. So we've already extended ray number 1 backwards, and all we have to do is extend ray number 2 backwards. Alright. The point where they meet is where the virtual image is produced. So right here is where our virtual image will be produced. Virtual image is produced. The image is diminished, upright, but virtual. Alright, so complete. Next question. Oh, this is a cheap question, by the way. Only achieved. Yeah. Tim used a convex lens to create an image of the small plant. The convex lens has a focal length of 40 centimeters. Draw 2 appropriate rays on the diagram below to show where the image of the plant will be formed. Draw the image in the correct position. Okay, so as you can see, in this question we have a convex lens. Okay, so you can do there's many variations to how you do this, but what I like to do, and I find it's the easiest way to do this question, is the ray that is traveling parallel to the horizontal axis, and the ray is going to pass through the point where the vertical and horizontal axes overlap. So if this was a coordinates graph, it will pass through the point 0, 0. Alright, I'm just going to show you what I mean, but I'm going to start off with the parallel to the horizontal axis ray. It's going to travel parallel to the horizontal axis, and then when it hits the lens, because the lens is made out of glass and the light is traveling in air to glass, there's going to be a refraction of the light ray, and this means the ray is going to bend. And when it travels back out of the glass and back into air, the ray is going to bend again. So how is this going to affect the direction of the ray? So this affects the direction of the ray. It's dependent on the lens, but as you can see, the focal points have been marked, and we can infer that the refracted ray will pass through the focal point. Okay, so what I mean is that refracted ray is going to be passing through our focal point. So passing right through our focal point there. Alright, so that's our first ray done. Our second ray, what I mean when I say passing through point 0, 0, is it's going to be passing through this middle part where the vertical and horizontal axes overlap. And this is the point where the ray actually doesn't experience any type of refraction, and it's actually just going to pass right through the lens. Okay, so it's just going to keep continuing going forward right through that 0, 0 point. Now that we've drawn these two rays, we can see that the real rays are overlapping. That means the real image is formed. And where the real image is formed is where these two intersect, and that is right at this point here. So our image will be produced right here, and that will be the real inverted and diminished image. This is a merit question. Okay, merit question means that everything is correct, while in achieved, that's only the two rays correct without the image. Alright, moving along. The images produced by the convex mirror and the convex lens are quite different. The convex mirror produces a virtual image, and the convex lens produces a real image. Explain the difference between a real and virtual image. Explain how Tim could detect the differences between the two images. Alright, so the three things you need to mention here. Real image is formed when the real rays meet, and virtual images are formed when only the virtual rays meet when we extend the real rays backwards. Another thing we have to note down is that the real images are always inverted, and the virtual images are always upright. And the one way that Tim can detect the difference is by using a screen. If I am able to project this image onto a screen, then it must be real. Only real images can be projected onto the screen. If it's not being able to be projected on the screen, then it must be virtual, because virtual images cannot be projected on the screen. So that's basically the 3 points we need to mention to get full marks for this question, okay? So all we have to do is link these into a full sentences, okay? So we're going to say that the difference, so we can say a real image is formed when two actual real rays meet, while the virtual image is when two virtual rays meet. Virtual rays meet, created by extending the real rays backwards. Alright, so we're going to mention that the real image is always inverted and the virtual image is always upright. The real image is always inverted, but the real image is always upright. Not real, the virtual, what am I saying? But the virtual image is always upright, is always upright. Alright, now we're going to explain how we've done the first part. Now we have to explain how Tim could detect the difference. Alright, so Tim could use up screen. If the image is able to be projected, then it must be real. But if it's not able to, be projected, then it must be virtual. And that's all you have to say to get the maximum mark for this question, which is a merit grade. 3 points linked correctly, that's the merit grade, while achieved is mentioning any one of these points, okay? So the 3 points are real rays, 2 real rays meet, virtual rays, 2 virtual rays meet. Real image is always inverted, virtual ray is always upright. Or you can say the screen, where the real image can be projected while virtual images cannot. Alright, sorry guys, I should have got rid of this before. Sorry. skip ahead in the video. Skip ahead. Skip. Alright. Tim places a 10 centimeters tall plant of a distance 60 centimeters of a convex lens with a focal length of 40 centimeters. Calculate the distance between the image and the lens, the height of the image, okay? The distance between the image of the lens, that's di, the height of the image, that's hi, okay? So what do they give us? They give us that small 10 centimeters plant, so they give us the height of the object, so the plant is 10 centimeters tall. So height of object we actually know is 10 centimeters. We know that the object is 60 centimeters away, so therefore the DO we also know is 60 centimeters. And we also know it tells us the focal length is 40 centimeters, so we can know F is 40 centimeters. Because we're dealing with a convex lens, the focal length is positive. But however, if we were dealing with the concave lens, then the focal length would indeed be a negative value. Okay, so in order to approach this question, okay, we have to figure out the DI, distance of the image and the lens first. Then we can use the distance of the image of the lens to figure out the HI, which is the height of the image. The first thing we have to do in this question, we need to use 1 over F equals to 1 over DO plus 1 over DI. We know DO is 60 centimeters and we know F is 40 centimeters. So 1 over 40 equals to 1 over 60 plus 1 over DI. If we move the 1 over 60 to the other side, it becomes 1 over 40 minus 1 over 60 equals 1 over DI. So basically, 1 divided by 1 over 40 minus 1 over 60, that's in brackets, and that equals to DI. And if we plug this one into a calculator, so if we just get a calculator, so 1 over 40 minus 1 over 60, 1 divided by our answer. That should give us that our DI is equal to 120 centimeters. DI should be equal to the 120 centimeters. So now that we have our DI, we can use another formula in order to determine the HI. We can use the DI over DO is equal to HI over HO. So we can use DI over DO equals to HI over HO. You know your DI is 120, you know your DO is 60, you know your HO is 10. So all you have to do is plug in your numbers. So 120 divided by 60, that equals to 10 divided by HI. So now we're going to cross multiply, okay? This multiplies this, and 60 multiplied by 10. So therefore 600 equals to 120. 120. So 120 HI. Oh, sorry. I know. Sorry, guys. I made a mistake. HI is at the top. Sorry, what am I doing? HI over HO, so 10 over 10. Yeah, no, not 10. HI over HO is 10. What am I doing? 1,200 equals to 60 HI. HI therefore equals to 20 centimeters. Yeah, sorry about that, guys. Don't know what I was doing. HI equals to 20 centimeters. That's your final answer. And that's your final answer for DI. So getting both of these correct, DI correct, HI correct, gets you your excellence grade. To get a merit grade, you're getting the correct DI only. So this only will get you a merit. To get an achieved, you can show proof of knowing the Descartes' formula. So this one here, achieved. All right, moving along. I'm going to cover question 2 in a separate video. Okay, I'm going to split this up into 3 parts: question 1, question 2, and question 3. So stay tuned for the next video. Thank you for watching this video. See you in the next one. Thank you. Bye.